Hi everyone and welcome to this new video of my web exploitation series. So we are almost at the end. In particular, in this episode we will talk about the brute forcing of credentials. Now, when we talk about brute forcing, the idea is similar to the ideas that we discussed in the enumeration episodes. So we showed how to enumerate files and directories, we showed how to enumerate virtual host, we showed how to enumerate HTTP parameters. Now, brute forcing is very similar to enumeration, but this time, instead of enumerating a resource like a file or a directory or a virtual host, we want to discover credentials. So credentials to authenticate to various services. So in this video, I will show essentially three examples. One, we will brute force SSH credential, then we will brute force FTP credential, and then we will brute force HTTP credentials. In particular, I will showcase two different scenarios for HTTP. One using the basic authorization header that HTTP allows, and another using a custom login implementation, and specifically we will brute force the login of the DEM vulnerable web application. Now, to do the first three brute forcing attempts, so the SSH, the FTP, and the HTTP with the basic auth header, basic auth, we will actually use a tool which is called legba. So this is not your usual Hydra. Typically, even in the OSCP material, it's mentioned Hydra to brute force things. However, recently I've discovered this tool. It's called legba. It's an open source tool developed by Evil Socket, which is an Italian security researcher. And this tool is really cool. It's fast, it's written in Rust, it's just modern. It's really interesting. So I prepare commands on how to use this tool for the brute forcing of credential. I hope you find the video useful. I hope in this video you can discover how legba can help you. And that's it. Enjoy the video. So we can go into the folder of the video. So brute forcing, we go into content, we go into legba. We will start with legba. So as always, what do I have here? Here I have three different scenarios. The first one we will analyze is the SSH login. So here I have a Docker file, this Docker file, and this Docker file creates a really simple Docker container with SSH credential. So the idea is that this container will only expose an SSH service, and we will use this to test our tool. It's sort of like a custom-made lab. Now, how do we set up this login, right? Well, notice that in this Docker file here, when I'm actually setting up the password, when I'm actually configuring the password, I'm running this echo command. The user is the hard-coded string SSH user. However, the password is an argument that the Docker file computes at runtime. So the idea is that during the build of the image, we will actually generate a password. And this password will be taken from a word list, and then we will use the same word list to brute force it. But of course, the cool thing is that so notice here I have this symlink which points to the previous directory, to the word list directory, to password.txt. If I open this file, I have just a bunch of passwords. They are not that many, they are like 62. They were taken from, I believe, the rocku.txt passwords. So one of those files that you can find in your Kali distribution. So it's a very common file, it's a very well-known file. These were the first lines of that file. Now, what is interesting to us for the content of this video is this. The docker build command that I will use is docker build. Then I say build arg, so this is like a new flag we never used before. Then I say password. Here I do this shell escape, this $ with the parentheses. And then I say shaf n1. And then I say passwords. And then I say t legba lab ssh. And then I do dot so that the Docker file will be taken from the current directory. Now, if I run this command, it's gonna build the Docker image. Now, what's the meaning behind this build arg password equals and all this stuff? The idea is that during the build time, a random password will be taken from the passwords.txt file. And this command in bash it's called like shell expansion. Essentially, this will expand to the internal, to the command within the parentheses. So if I just write shaf n1 passwords, notice what do I get? Mustang. I get one of the line in the passwords.txt file. If I repeat once again the command, I get another password, which in this case is password. I can repeat it many times. This is also fuck you, I mean this interesting password, right? If I just repeat it many times, I get different password. So that's the idea. When we build a Docker, we are picking one line out of the like 70 lines that are in the file, and we are using that as a password. This is to make sure that I do not know prior, before actually executing the container, the specific password that has been chosen. So we can brute force it with legba. Now, we have created the Docker image. Now we have to run it. And to run it, we can do the following command. Docker run, rm to delete it and every time we stop it. Then I say network host to make sure that the 22 port that exposes the SSH service will be available in our localhost interface. So I don't need to connect port between host and the Docker. All ports will be shared. Then I do -t and then I say legba lab SSH, and then I say a dot. Actually, I don't need a dot here. So I can do this, and it runs the Docker in another shell. Now that the Docker is executing, the 22 port of my localhost is now open for receiving SSH connection. So to connect with it, I will do SSH user at 127.0.0.1. I don't need to specify the port because the default port 22 will be good, will suffice us because that's where the service is listening. Now, if I just run this command, notice what we get. Like this, the client, the SSH client is asking us and is saying, look, I cannot verify the authenticity of this host. This is the fingerprint of its public key. Do you trust it? Do you want to trust this or not? Actually, we do not want to trust this because this is just for like a small experiment. And then we will just trash the server and we don't care about that. So to avoid this saving, we can do this. We can do -o user known host file equal devnull. Equal devnull, so that even if we save the key, it's actually gonna save it to the driver devnull, which will discard it essentially. So now we can say yes, perfect, and now we can give a password. So for example, I can say password. And of course, this is the wrong password. I can say password test. Of course, this is the wrong password again, because I don't know which among these 70 passwords is the one that was picked during the build time. So the idea of brute forcing is really simple. We will just keep making a lot of requests, each with a different password, until we find the correct one, until we find the one that correctly authenticates us to the service. So the idea of brute forcing is really simple conceptually. The idea is we will try a lot of different passwords, and if the password blocks us, like this, if we get a permission denied, then we discard the password. Otherwise, if we find the correct password, we tell the user. And this is essentially what brute forcing tools do. They just make a lot of requests. Now, of course, you have to be careful to do such attack on a real system, because the fingerprint of this attack, the fact that it can be easily recognized because you are generating a lot of traffic, so you have to be careful. But in this example, since we are executing locally, we don't really care about that. So we're gonna use the tool legba, as I said. Now, how do we use this? Well, the idea is that to actually use it, we can first download the image. We can do docker run it evil socket /legba, and we can say -h to download the container, and it gives us all the various options. So the first time it's gonna download the container. I have already downloaded it, so there's nothing too much to say about it. Now the next thing we'll do is we'll execute a Docker with legba, and we will execute a shell within the Docker. So once again, remember the previous video where I showed how to enumerate HTTP parameters. In that video, I showed how to use wfuzz, and I was actually using wfuzz inside a Docker container. I do this because it's easier to run it within a Docker container so that I don't have to install all dependencies, I don't have to deal with building problems maybe, with the deprecation of old packages that this program uses but that I do not have installed on my system. Everything is handled inside the Docker, which is very, very comfortable, I would say. So how do we run this Docker? Once again, we do Docker run. Then we do entry point and we say, look, in the entry point, I actually want a shell, so bin bash. Then we connect the folder, we do amount of folder, current directory with the data directory within the Docker. Once again, we do network host. This is important because the legba Docker has to be able to communicate with the SSH Docker. Then we do -et to make it interactive, and then we do evil socket legba latest. We do this and we have a shell within the Docker, and now if we do which legba, we find our legba. We can do legba help, we get all the help menus and things of the sort. Now, how do we actually execute it, right? So legba is really simple. It has a really intuitive interface. We start with the mode of operation. So which protocol do we want to brute force? Because of course, for each different protocol, we will have a different flow of messages. So if we want to brute force SSH, we will have to generate a bunch of bytes, the ones that match an SSH connection. If we want to brute force FTP, once again, we have a different bunch of bytes. So the idea is that we have to repeatedly send all the bytes that perform an authentication attempt, a login attempt. In this case, it's SSH. Then we can do -- username. We say SSH user because it's hard-coded. Then we say the password. Here we put /data password.txt because this is the file that contains our word list. And then we put the target. So the target is 127.0.0.1, very simple. We don't have to specify the port. Why? Because the port is the default one by SSH. So we execute this. It starts to run. It tells us, okay, apparently it didn't work because it did not find the correct folder. So there is an error here, and the error probably has to do with how I executed this. So I think it's, let's say, current work directory /data. Okay, let's do the same command, but let's do word list, and then say /data. What about this? If I go into /data, okay, now I have the password.txt, so now I actually have the word list. And now if I execute, so legba ssh, username ssh user, password, data, password, and then I say target 127.0.0.1. Let's say now it's reading all the password and it's trying all the password. Notice now that it's taking a bit of time because it's reading all the different passwords. Here we get a percentage of how much we scan the file and how many passwords we tried of that file. And if we wait a little bit, okay, look at this. It found a valid credential, SSH user Robert. So let's try with the credential found by legba. So we do SSH, then we do this thing about the saving of the host fingerprint. So we don't care about that. We say yes, whatever. We say SSH user. No, it's not the password is not SSH user. That's the user. The password is Robert, right? Because look at this. It says, look, these are the valid credential and this is the password. And now I'm gonna put the password into the prompt. And now I am inside. So I've brute forced this SSH login. And notice how easy that was. We just run the command of legba. I mean, you should not do this on a server you have not access to, of course, because that would create problem. It's not a good thing to do. You would just spam someone of traffic, but it's really, really simple. And when you're doing maybe a penetration test, when you're doing a CTF, an OSCP exam and stuff like that, this command is extremely intuitive, I would say. I mean, look at this. It explains itself, right? I don't even need to explain it. It's the protocol, the username, the password, and the target. And notice here in the legba wiki, there are some other examples. So let's say that you have a different port, then you can specify it by doing a target the IP address or the domain name, you do the colon, and then you put the number of the port. This is another way using the SSH key-based authentication. So with the public and private key, you just say password, and then you put here the path where you can find your keys, and then you say SSH auth mode key. So very, very useful. So this ends the first demo. So the first demo was trying to brute force SSH. Now I can just stop the container. I'm gonna use essentially, so this is legba SSH. I'm gonna say, oh, stop. So this was the Emacs interface for Docker. We don't care about that. Then we can go into the FTP directory. Once again, we're gonna do the same thing, but for FTP. So this is another configuration for FTP. And here is a link to the GitHub where I took inspiration. I simplified a little bit. Once again, notice this. We just say password, and the password is taken from an argument. So how do we build this thing? As usual, it's the same thing. We just do docker build arg password. Then we say with the common expansion shaf-n1 passwords.txt. Then we say t legba lab FTP, and then we say a dot so that it takes the Docker file from this particular directory. It executes the Docker image. It says, look, I changed the password for the FTP user this time. So we can actually run the Docker. So we can say docker run rm to remove it. Name, we can give it a name also. Legba lab FTP, network host, DT. We can also do just T. T for interactive, D will be for daemon mode, but we don't care about that for now. So we can just use the shell. Okay, so let's see. I think here, am I inside? Okay, maybe we don't care about that. So we can say just D once. The container is already in use, so we can just close it, I suppose. We can just close it. Docker legba FTP. So I'm stopping now the container. It's taking a while. So now I stop the container so I can start it again. Okay, now I start it again, it ran, and now we can try to log in. How do we log in with FTP? With the command FTP. So we can say FTP 27001. It says connection refuse. Let's see why. Okay, now it works. I understood the bug. The bug was that I had commented this line. So I had to rebuild the image with the command docker build. So to build the image is this command. So it's docker build with the argument with the password taken from the file, and this is the name of the image. And after I've built the image, I can just run the docker with the docker run, with the network host, with the daemon mode, and that's it. So now the docker is running. I can connect with it via FTP. So I can say FTP user and I can specify a password. Of course, once again, I do not know what is the correct password. So how do I deal with this? Well, once again, we use legba. This time, of course, it's not gonna be legba SSH, it's gonna be legba FTP. So legba FTP, then we can say username, FTP user, password, data passwords, and we can say target 127001. Let's say if this works. Sometimes in my test it crashed the server, so that could be like we would recognize it. So notice this, I think it actually crashed the server or something. Yes, so the server is crashed. Okay, so now it worked before crashing the server actually. So it crashed the server a bunch of time. I had to rebuild it so that the password would be like one of the first lines of the text file. Now I don't know exactly why at some point this just like turns the connection and closes the Docker. This is like out of the time I have spent for studying this thing. But essentially these are the credentials. So FTP user and baseball. Once again, just notice how easy is the legba command and how intuitive it is. We specify the name of the protocol, the username, the password, the target, and it takes care of all the details. Of course, this is not as easy as it seems because there are a lot of details here that I'm skipping because of time. But essentially, for example, in this case, one would have to analyze why is the Docker crashing and how to reduce the number of queries and how to like limit the number of connection that the legba makes to the server in order to not crash it. So that's the idea. This is our second scenario. Now for our third scenario, we will build an HTTP server with a basic authentication method. So here the docker build command is a little bit more complex because we will actually do two things in here. So this is the command. Now in the password we will actually do this. And what does it do? This computes essentially an OpenSSL command, so like it hashes a password. So first we get the password, then we hash it. So if we execute this on our shell, we get here a bunch of hashes. So we can say echo this. We get a bunch of different hashes. So that's the idea, essentially. And then we're gonna build this thing. So we build this. Also, I think I can just stop okay, no, I think I stopped it, right? Because it's just legba, right? Yes, it's just legba. So I've built it, and now I can run it. To run it, I say always run rm name legba lab HTTP network host legba lab HTTP. So this is running now. It's accepting PID, so we can just open a browser and go to localhost. So when we go to a browser and we go to localhost, here we're met with an authentication form. So we say HTTP user and we put a password. Of course, this password is not correct, and with legba we will find the correct password. So how do we do this? Well, as always, here we have our shell with legba, right? So we say legba http.basic username HTTP user password data passwords, and then we say target HTTP 127001. We wait a bit and look at this. It found HTTP user let me in, which seems pretty right? So now with the credential found by legba, we can say HTTP user on the username, let me in on the password, and boom, we are inside. We have found the correct password. So once again, how is the command with legba? It is extremely simple. Now, before moving on to the final example in which we will write manual code to brute force a login, I just want to showcase just how simple this is. So notice all the legba commands that we use so far. So this is for the HTTP, for the FTP, I'm gonna put it up here, and finally for the SSH, I'm gonna put it up here. So it's pretty much the same, it's just that changes the initial protocol, but overall the logic is the same. It is very, very intuitive. So this brings us to the last example. So we can close all these containers. So we have essentially these containers. So this one we can just stop it. It's stopping, perfect. And now we can go into DVWA. Perfect. So now we have, what do we have here? As always, we start the WVA, the then vulnerable web application container. So we just do docker run and we have our application. Now in terms of the login that we want to brute force is the initial login of the application. So specifically, I want to brute force this login. So let's say that we do admin password to just initialize the database. So I'm just going to initialize the database and then I log in, right? So what I want to brute force is this one, is this login, right? So how can we brute force such login? Well, it's actually not that hard, and here I have written the code. So this is the code for brute forcing the login. So let's try to read it. So this is Python code. We are using two libraries, the request library to perform a HTTP request and the beautiful soup library to read HTML code. Because the idea is that between our client and the server, we will make multiple requests, one after the other. And from the response of the server, we will extract from the HTML specific piece of data. And so we need to parse the HTML, and to do that we will use beautiful soup. Here we put like the URL, so we put HTTP DVWA login. We actually don't even need this DVWA, it's just login. We don't need the proxy. We put the password word list, username word list, so these are just files which contain a bunch of usernames here. I mean, there are not really that many, but this of course is just for test, and a bunch of passwords as always, taken from RockQ. So this is good, and then we have the main function, the check credential functions. This takes a username and a password, and it checks if that username with that password is able to authenticate to the web server. How do we call this? Well, in the main loop here, in the if name equals main, which is executed when we call Python 3 login brute force. So when we do this, this thing is executed. We read all the usernames with this open read split lines. We read all these passwords with the same syntax, and then we iterate for each user and password. We check if the credential is valid. If it is valid, we print them, and then we do an exit to exit the loop. So that's the idea. So how does this work? Well, the first thing is we're gonna have to make a request to obtain the CSRF token, so the CSRF code. So this is important because otherwise the next request will not be valid. So the idea is that we have to simulate a real client, and what does a real user do? First, it fetches the page with the GET request, and then it performs the login with the POST request. So this first request will simulate a normal client. Then from this request, we extract the cookie header. So we do from the headers, I want the PHP SID equals, I want to split it, I want to extract the values, and specifically I want to extract everything that comes before the semicolon. So I want the first value of this. So this is the idea. Then we sort of like initialize the parser with the text response. So with the body of the server response, we extract this token using the beautiful soup syntax. So we go into the input field, specifically the one where the name of the HTML has the value user token, and we extract the attribute value from this. So if we just check the essentially the HTML, look at this. So we just refresh the page. We just want this. So this is what we want. We want the input field that has the value user token for the attribute name, and then from the attribute value, this is the CSRF token, which is used to validate the second request, which is the request that actually has the credentials. So let's go back to the code here. So now we prepare the data for the second request. So we do username equal username, password equal password, login equal login, and user token equal the token. How do I know this? Because I've analyzed the request with Burp Suite. You can do it with any sort of login. You can understand the format, and then you can just redo it in Python. And then we make the second request, which is a POST request. So we put our custom headers. So our custom headers contain the content type with application xwww form URL encoded to tell the web server, look, I'm sending you data, process it. And then we put the cookie with the value that we found before, so that the CSRF token is validated, because the CSRF token is associated to the cookie value, to the session token that is used to like keep track of the session of the user. So we have to use the same cookie we got from the first response, and then we send a post with these custom headers, with the custom data. Here the proxies I can remove because we don't need that, and then I say, look, allow redirects false, which means do not follow redirect immediately, follow manually. So then we manually follow the redirects. We can remove this proxy. At this point, if we get login failed, we return false, otherwise we return true. Let's try to execute this. So what do we get here? I get Python login brute false. It says, look, here it says, okay, I need to remove this proxy. Need to remove this because we don't need proxy. And then, so let's say login brute force. Print found credential, login brute force. So let's say print hello. Does it even work? Okay. But I'm not sure if it has the proper, let's see, login.php. It's login.php valid? Yes, it seems to be valid. Let's do localhost here. Localhost, login.php. Seems like it's not printing anything. Print user, print password. Okay. Oh, okay. I think it's because I've actually mistaken this syntax, actually. Okay, now it works. So before I had a list which contained another list, so this is why it didn't work. Now I just have a single list which is obtained with a split lines value. So now it found the credential and it says, look, admin and password is actually valid. And if I say admin and password, now it says the CSRF token is incorrect because I have to refresh it, admin and password, and I am inside. So this is another example of how you can manually implement custom authentication logic to brute force a specific login. Of course, the same thing could be done with Burp Suite. and also with legba. So we could also use legba to do this sort of exact same thing. I think it's useful to understand how you would write custom logic like this for maybe a specific login that you cannot automate it with a tool. So this is why I also wanted to show it in the end. But this is it for this video. I hope it was enjoyable. All the code and the commands you will find in my GitHub. So see ya to the next video. In the next video we will finally finish the web exploitation series by talking about DNS zone transfer attacks. So see ya to the next video.